Welcome back. Today we're going to be doing part 2 of our transport experiment. And in this experiment, we're looking at the movement of various molecules, 3 different ones, through a semi-permeable membrane. The semi-permeable membrane we're using today is a piece of dialysis tubing, and some things can move through this and some things can't, and it's based upon the molecular weight or basically size of the molecule. So we're looking at 3 different molecules today. Starch, which is a large molecule, sugar, which is a very small molecule, and iodine, which is sort of a medium to small molecule. And we're going to be looking to see whether these 3 molecules, any of them, can move through this semi-permeable membrane. So the first thing we have to do is we have to put some of the molecules inside this little bag that I'm creating. If you can see, I've tied a knot at one end of the tubing, and then the other end is still a little bit open, which will allow us to put the sugar and the starch inside the bag. Once the bag is full, we're going to tie it up. We're going to rinse off the outside of the bag, and then we're going to put it in the iodine solution, and then we're going to see if things can move back and forth across the membrane. All of these solutions were made using distilled water, and distilled water has very low or no solute, no stuff in it. So we don't have to worry that my tap water has any sugar or starch or anything in it that would influence our results. About 3 milliliters of starch. So it's up to the 3. So we're going to put in 3 milliliters of starch inside the bag. Here's the tricky part. You can see that there's some starch inside the bag now. And then I'm going to put 4 milliliters of sugar inside the bag. Okay, so you can see that the starch and the sugar are inside the bag. And what I'm going to do is I'm going to tie a knot at the top of the bag to make sure that anything that moves inside or outside of the bag is going through the bag, not in and out the top. Then we have a little bit of extra material here, which I'm going to cut off. I left it long because it's hard to cut. Or it's hard to tie. And now what I'm going to do is I'm going to rinse off the bag in distilled water. And the reason we want to do that is we want to make sure, again, that there's no starch or sugar on the outside of the bag and cheating. So we're going to rinse that nice carefully. Make sure that there's no starch or sugar on the outside of the bag. Okay, so now we have our bag, and the bag has the starch, which was the large molecular weight molecule, and sugar, which is the small molecular weight molecule, inside the bag. We're going to put it into a jar of iodine, and I want to show you what's going to happen when starch and iodine combine. When starch and iodine combine, they form a blue-black precipitate. So I'm putting a little bit of starch into this shot glass and adding just a little bit of iodine, and you can see what's going to happen. So very definite color change there. Now we won't expect to see that right away because, again, the starch is going to be inside the bag at the beginning of the experiment, and the iodine is going to be outside of the bag. And by looking to see where the color change happens, we can tell whether it was starch moving out or iodine moving in. Now it's not so easy with the sugar because sugar doesn't form a color with either one of these other molecules. So what we're going to end up doing is at the end of the experiment, we're going to use something called Benedict solution. Benedict solution is blue, as you can see. And when we add it to the material that's inside the jar, inside the beaker, versus inside the bag, we're going to be able to test for the presence of sugar, because Benedict solution, when it has sugar near it and you heat it up, turns like a red brick, kind of brownish color. So we'll see that next. The first thing we're really looking for is whether iodine and starch are going to move. So we're going to stick this in to this beaker of iodine, and we're going to wait 30 minutes. So there it goes, and we'll see you in 30. Okay, welcome back. It's been 30 minutes, and as you can see from our bag, there's definitely blue coloring inside the bag. And what you can also see is that the iodine does not have any blue. So the reaction between starch and iodine happened inside the bag, not outside the bag. So we can tell from this, if you think about it for a minute, which way and what moved. So when starch and iodine get together, it makes something blue. There's no blue in the iodine, which was outside the bag, so starch did not come outside the bag. But there is blue inside the bag, so the iodine must have gone into the bag. Now the tough thing is, again, that even though we can see which way starch and iodine moved, we can't tell what happened with the sugar. And remember, the sugar started inside the bag. So what we want to do next is we have to use some of the liquid from inside the bag and some of the liquid from the beaker, and we're going to add Benedict solution to both of those, and we're going to heat them up. And that's going to tell us whether the sugar stayed in the bag or whether it came out and went into the beaker. So let's look at that next. And we're going to set up for the Benedict solution experiment. So we've got kind of a bunch of jars here that I'm trying to use. So we're going to put the contents from the bag in this jar. We're going to put the contents of the beaker in this jar. So we want to make sure that it's the sugar started in the bag. Did it stay in the bag, or did it also leave and go into the beaker? We're also going to do a negative and a positive control. So the negative control is just going to be straight water. You shouldn't see any color change in that one with the Benedict solution. And the positive control, I'm just going to put some sugar in there, and that should definitely be positive. So let's go ahead. We'll do some of those. Now, normally scientists will not label the top of the jar. I would have a grease pen, and I would have test tubes, and I would have all kinds of fancy equipment in which to do this, but since I'm at home, I don't have it. For the positive control, I'm going to use dextrose. So I'm going to just put a little bit of this into the jar. For the negative control, I'm going to use just a little bit of water. Positive control means that you definitely should see a color change. Negative control, so there shouldn't be any sugar in it. We're going to take some fluid from the beaker, put it in this one. And again, you're supposed to measure it out, but I don't have enough things to do all the measurements. And then the bag, we're going to very carefully cut the bag and put some of the fluid from inside of the bag in here. So remember, the sugar started in the bag, so you would think you would have some sugar in there. But the big question is, was the sugar able to leave the bag? Now, we're going to put 2 milliliters of Benedict solution in each of the jars. Benedict solution will change color when it's heated in the presence of a reducing sugar. So if there is sugar, it'll turn color. Okay, now each of these, you can see, kind of looks to be very similar in color right now. Only one that's different is the one that came from inside the bag. This doesn't seem to work. These, by the way, are shot glasses. And then we're going to take each of these and we're going to put them in a hot water bath, which is going to sit in here. Ouch, hot. For 10 minutes. Okay, we're back. It's been 10 minutes. I'm so excited. Are you so excited? Oh, yeah. So first we're going to look at our negative control. This is the one that we don't expect to see a color change, and yay, we didn't see a color change. Our positive control was our straight sugar solution, and you can see that it turns sort of a rusty red color. So this definitely had sugar in it. Now, which one should we do? Beaker? All right, so if you look at the beaker, there's definitely some sugar in there. So it was obviously the sugar was able to cross that membrane and get from the bag into the beaker. And in the bag, there's lots of sugar also. So what this tells us is that the experiment worked properly. All right, so this should help you understand how the transport works across a semi-permeable membrane. Again, your cells are semi-permeable membranes, and some things can go right across, some things can't. Thanks for watching. See you in class.